Welcome back to my stats lecture. We're going to be continuing our discussion about data summarization, but this time we're going to be talking about measures of dispersion. So we have dispersion, spread, and precision. Now the good news is that these are all the same thing, except that precision is just another way of looking at it. So for dispersion and spread, the main two we're going to talk about is variance and standard deviation. For spread, we're also going to include the range for spread and dispersion, but for precision, we're just going to call that inverse variance. Okay, so variance has a simple formula. It is also known, so the variance is also known as the second central moment of a distribution. And just like before, we're going to be looking at all of these summarizations of a distribution, okay? This is all relative a distribution. So the formula, for variance, we're going to denote a Greek s squared, and this is equal to the summation of the random vary itself minus its first raw moment or its measure of center squared times the probability density function of that random variable with respect to the variable. This is, again, let me grab this. This is continuous, and this is for the population. Now, if we're talking about a discrete random variable, it's the same thing. We're going to use a capital Greek S. We're going to still be second and central. So this denotes second order, and then this denotes centrality. Subtracting off the mean denotes centrality. We need to remember that for later. And then this is still times the probability density of x. Now, because it's discrete, I can denote this with an I here and an I here. Instead of, so from calculus, this is basically your denotation of indexing, and in discrete, so this is a discrete random variable, and this is also for the population. Okay, so one thing we need to note here is for the standard deviation, we are simply taking the square root of the variance. So nothing changes. So the standard deviation is equal to the square root of the variance. And so all I have to do is put a square root symbol over either of these two formulas, and I will get our standard deviation. Now, this is talking about a population. Let's talk about a sample variance. So again, we're going to denote this. We're going to denote this as s squared. And again, just like we did before in the mean, we need to assume a random sample. And the reason we need to assume a random sample is that we need this probability of selecting an individual in our sample to be equal between all individuals. So now I can do 1 over n minus 1 degrees of freedom times the sum of x minus x bar squared. Okay, so what's happening here is that in the population, I knew the population measure of center. However, when discussing a sample variance, I don't know the population measure of center. I only know the sample measure of center, x bar, our sample mean. Because of that, I need to consume a degree of freedom from our sample, from our sample in order to calculate the probability of each individual in the sample. All right. So this is our formula for our sample variance. And our sample standard deviation is just going to be the square root of our variance. So we're just going to throw a square root symbol over this. So what you'll want to do is you'll want to calculate this either by hand or using a calculator, and then just simply take the square root of it, and that will give you your standard deviation. The next thing we want to talk about is our range. Range is simply the max value. So let's say we have a random variable x. The range is the max of x minus the min of x. Range is typically reserved for samples. So if an example of this, if I had x equal to 0 to 4, my range of x would be equal to 4 minus 0, which is equal to 4. That's it. That is the range. Now, for precision, precision is simply the inverse of the variance. So my precision of x is simply equal to 1 over the variance.